Hi guys, today we're going to review exponential functions. We only did them a little bit back a few months ago. So let's review how to type them into the calculator and what they look like. So first we're going to graph this function on the grid provided. So let's type it into our y equals. Please take out your graphing calculators. We're going to do y equals, clear what's in there. If your plot 1 is highlighted, please go up and turn it off so that we can see the graph. If you get an error message, it's probably because your plot 1 was highlighted. So in our y equals, we're typing 2 to the x minus 1. So 2 caret, so to the power, so carets above the divide. X minus 1 is the whole exponent. You can right arrow to get off of it. Let's hit table to get the values. Second table. So usually we like to go like -3 to 3. So on this one, maybe it's a little bit, sorry, maybe -3 is a little bit much. So we'll go -2. And it's 0.125 or 1/8. -1.25 or 1/4. 0, 1. 1, 2, 3, 4. And 4, 8. All right, so now we're going to try to graph these. So -2 1/8 is very shallow. -1 1/4. 0, 1. 1, 2. 3, 4. I'm sorry. 2, 2. I missed. My numbers are off a little bit. 0 was a half. 1 was 1. 2 was 2. 3 was 4. 4 was 8. Sorry. 0 1/2. 1 1. 2 2. 3 4. 4 8. So I just wanted to do the numbers that I put on my graph. So I'm going to try to connect these. It's a smooth curve. So do the best that you can on the surface. What is the y-intercept? So our y-intercept is the number where when x is 0, y equals what? So we can read it off our table. We can look at the graph. The graph's a little bit tricky. So it's 1/2. Domain, remember highlighting these? Domain is how I travel left to right. So the domain is going to be any number that we want. I can plug in any number for x, I'll get an answer. The range, however, is a little bit different. The range is bottom to top. When we're graphing these, we're going to get close to the 0, but we're never going to touch it. So it's always going to be really, really close. So our range is going to be from 0 to infinity. Is this graph increasing or decreasing? So what does it look like? It looks like it's going uphill. Do you agree? It's getting higher and higher and higher, so it's increasing. Explain how the graph of y equals 2x minus 1 translated to the graph of 2x. So we're not going to do that one. You could type it into your graphing calculator and see how it moves. But that's a whole unit that we didn't cover right now. So for example 2, let's just change this function. Let's graph y equals 1/2 to the x. And then we won't do part B. So go to your graphing calculator, clear out what's in there. We'll do 1/2. So alpha y equals gives us the fraction. So 1/2. Get off of it by right arrowing. Caret x. Second table. So we'll go from -2 to 2. So at -2 we have 4. At -1, we have 2. At 0, we have 1. At 1, we have 1/2. And at 2, we have 1/4. If we got -3, it would give us 8. Just to have one more point up here to see how it's connecting. So this one is starting tall and then decreasing. It does not actually cross over the axis. So this is a decreasing exponential function. Before we looked in the parentheses, so the general form of an exponential function, if you remember, is y equals a times b to the x. When a gives us the initial value, or the y-intercept, b is equal to our rate. If it's greater than 1, it's increasing. If it's between 0 and 1, then it's decreasing. So before we went through and we looked at the percentages, we said what the initial value was. That was the unit that we covered already on this topic. So now what we're going to do is we're going to make it into scatter plots and look at the graphs and compare linear versus exponential. So linear looks more like a line, exponential looks like a smooth curve. The breaking strength, Y in tons of a steel cable with diameter D in inches is given in the table below. So what we want to do is take a look at this. So we're going to hit stat, edit. We're going to type in the data. We're just going to do a sketch here. So we're going to cross this out and we're just going to do a sketch. So clear out list 1 and clear out list 2. So in list 1, we put our x values. So 0.5, 0.75, 1, 1.25, 1.5, and 1.75. In our list 2, we're going to do 9.85, 21.8, 38.3, 59.2, 84.4, and 114. We go to our y equals, clear out what's in there, go up and turn the plot on. Then we're going to go to zoom 9. It's hard to tell by just glancing at it if it's exponential or linear, but if we use the data they gave us, it definitely looks like it's curving more. So this one is going to be an exponential regression. So now we have to go and get the exponential regression it told us. So we go to stat, calculate. So it says here, stat calculate 0. So we go down all the way to 0, hit enter. List 1, list 2 is correct. We'll hit enter. So y equals 4 point, to tell us how to round, nearest 10th. 4 point, so let's do this better. So a equals 4.8, b equals 6.8. The general equation for an exponential is y equals a times b to the x. So y equals 4.8 times 6.8 to the x power. Example 4. Example 4 is an exponential regression equation. We have to make the equation. So we can't really tell what the y-intercept is here. So we have to take some points that we can tell, and then we'll type it in and do the regression. So the first point I can tell clearly is 2, 1, 3, 2, 4, 4, 5, 8. So I have these points. I have 2, 1. I have 3, 2. I have 4, 4. And I have 5, 8. In our next lesson, I'll show you how to use the pattern to figure out the equation. But because we have the regression key, we can type these in. So we go to Stat, Edit. We're going to clear list 2 and clear list 1. Type in our data, 2, 3, 4, 5. In list 2, we're going to put 1, 2, 4, 8. We're going to go Stat, Calculate, number 0, enter, enter, enter. So we get A equals 0.25, B equals 2. Our general equation is y equals a times b to the x. So y equals 1/4 or 0.25, 2 to the x. So I'll explain how you determined your equation. A lot of the Regents exam, which you fortunately don't have to take, is to justify or explain. So you could say I calculated the exponential regression by using points on the graph. This would be a 2-point Regents question. All right, please try example 5. You're gonna list 1 is the number of coins. List 2 is how many coins were returned. You're gonna write the regression equation to the nearest 10,000. So that's 4 decimal places. And then use it to predict how many coins will be in the box after 8 trials. So then you're gonna have to plug in 8 for x to see how many coins you would get. Try that one. Thank you so much.